I would say 30 to 40% that it's not a natural object because we don't see a beautiful tail behind.
In early October 2025, as the interstellar object officially designated 3I Atlas made its closest approach to Mars, 2 European spacecraft unexpectedly found themselves with front-row seats to a cosmic event unlike any in history. The ExoMars Trace Gas Orbiter and Mars Express, both operated by the European Space Agency, ESA, were never designed to study interstellar objects, yet at just 30 million kilometers from the visitor, they became humanity's closest observers of this rare phenomenon. The challenge facing scientists was immense: to capture meaningful data from a faint, fast-moving body hurtling through space at tens of kilometers per second. When the Color and Stereo Surface Imaging System, CASIS, aboard ExoMars began taking exposures, its sensors revealed a subtle but unmistakable glow, a tiny, blurred patch of light at the center of the frame. That faint dot was 3I Atlas, and what appeared in those images was not the comet's solid nucleus, but its coma, the diffuse halo of gas and dust released as sunlight heated the icy surface. The nucleus itself, likely only a few kilometers across, remains unresolved, but the surrounding coma spans thousands of kilometers, softly illuminated by sunlight scattered off dust particles. This marks the first time an interstellar object has ever been imaged in such detail from the orbit of another planet. The bright haze indicated that the comet's frozen ices, likely a mixture of water, carbon monoxide, and carbon dioxide, were sublimating under solar radiation, releasing jets of vapor that dragged dust grains outward to form its luminous envelope. Measuring the full extent of the coma is difficult because its brightness fades rapidly with distance from the nucleus, blending into background noise. But early estimates suggest it could stretch for several thousand kilometers. Notably, no obvious tail has yet been observed, the kind of long, filamentary structure typical of comets within our own solar system. The lack of a visible tail suggests that outgassing is only beginning as 3I Atlas accelerates toward its perihelion, the point in its orbit closest to the Sun, expected at the end of October 2025. Principal investigator Nick Thomas of the University of Bern, who leads the CASIS camera team, noted that the target was up to 100,000 times fainter than typical Martian terrain normally imaged by the instrument. Meanwhile, the Mars Express spacecraft also attempted to detect the object using its own cameras, though its shorter exposure times, just half a second, compared to ExoMars' 5-second limit, have so far produced no confirmed detections. Scientists plan to combine and stack many of those shorter exposures to enhance the signal and perhaps bring out the barely visible glow of the comet against the star-filled background. Both orbiters also tried to collect spectroscopic data, which could reveal the composition of the comet's gas and dust, but it is still uncertain whether 3I Atlas was bright enough for these instruments to register meaningful spectra. Analysts are continuing to reprocess the data, using advanced stacking and filtering techniques to separate the comet's signal from background noise. While ESA's orbiters gathered their data from above, something equally extraordinary occurred on the Martian surface. On October 4, 2025, one of NASA's Perseverance navigation cameras unexpectedly captured a faint glowing streak moving across the Martian night sky. These cameras, designed primarily for terrain mapping and hazard avoidance, are not optimized for astronomical observations, yet the image unmistakably shows a bright, elongated line believed to be 3I Atlas itself, passing within about 38 million kilometers of Mars. The photograph quickly gained attention and was featured as NASA's Image of the Week. At first glance, the streak appeared enormous, seemingly tens of thousands of kilometers long. However, closer analysis revealed a more mundane explanation: motion blur. Because the comet was so faint, Perseverance's imaging team had to combine hundreds of short exposures taken over several minutes. During that time, 3I Atlas moved relative to the background stars, producing a long, bright trail. Each pixel in the image corresponds to roughly 12,000 kilometers at the comet's distance, so the apparent streak, which spans several pixels, vastly exaggerates its actual physical size. Earlier measurements by NASA's SPHREX mission had placed an upper limit on the nucleus diameter at about 46 kilometers, assuming a typical reflectivity of 4%. If the object were truly tens of thousands of kilometers long, as the blurred image implied, it would have been easily resolved by the Hubble Space Telescope during its July 2025 observations. Yet Hubble detected only a single unresolved point of light. This ruled out any physical structure corresponding to the streak and confirmed that the effect was purely an artifact of motion. Despite online speculation about alien megastructures or spacecraft, scientists quickly established that the stripe was a visual illusion caused by imaging techniques. Still, this marked a milestone in planetary science, the first time an interstellar object has been imaged from the surface of another world. At the same time, the Mars Reconnaissance Orbiter, MRO, also targeted the region of the sky where 3I Atlas was predicted to appear. Its HiRISE camera, among the most powerful ever sent beyond Earth, achieved a resolution of roughly 30 kilometers per pixel during its October 3rd observation, over 400 times sharper than Perseverance's navigation cameras. These data, once fully processed, are expected to provide the most accurate estimates yet of the comet's true brightness and possibly even its size. Ironically, the release of results from NASA's side has been delayed due to a partial U.S. government shutdown, which suspended updates from several official channels just as the interstellar flyby reached its peak. This has fueled online speculation and frustration within the scientific community as public access to the latest Mars observations was temporarily restricted at the very moment researchers were eager to analyze and discuss them. Despite the temporary blackout, independent astronomers and ESA teams have continued sharing updates. 3I Atlas, discovered earlier in 2025 by the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Hawaii, is the third confirmed interstellar object detected passing through our solar system, following 1I Oumuamua in 2017 and 2I Borisov in 2019. Unlike Oumuamua, which showed no visible coma or tail, 3I Atlas behaves much more like a traditional comet, with detectable outgassing and a growing envelope of dust and gas. Its orbit indicates an unbound, hyperbolic trajectory, meaning it is not gravitationally tied to the Sun and will eventually leave the solar system again, never to return. Observations show that the object is traveling at an extraordinary velocity, currently around 60 kilometers per second and expected to reach nearly 68 kilometers per second at perihelion. In late September, a coronal mass ejection from the Sun reportedly struck the comet's vicinity, potentially energizing its coma. But follow-up imaging on September 27th and October 2nd found no evidence of catastrophic changes, no breakup, no tail detachment, and no fragmentation events. The coma appeared stable with only gradual expansion, suggesting that the object's structure is robust and its activity steady rather than explosive. One of the central scientific questions concerns the mass and density of 3I Atlas. Determining the size and mass of a cometary nucleus is notoriously difficult because its visible extent is dominated by the surrounding coma. To address this, a team of researchers led by Harvard astrophysicists Richard Kluda, Avi Loeb, and Peter Vess analyzed its trajectory based on data from 227 observatories collected between May and September 2025. By comparing the observed path to the theoretical one predicted under pure gravitational motion, they detected a tiny but measurable non-gravitational acceleration, a sign of weak thrust from outgassing jets. However, the magnitude of this acceleration, less than 15 meters per day squared, was far smaller than expected for such an active comet. From these calculations, the team estimated a total mass exceeding 33 billion tons and a diameter of roughly 5 kilometers, making it several orders of magnitude more massive than any previously observed interstellar object. Avi Loeb has argued that if interstellar space contains enough debris to produce one such massive object, we should have detected many smaller ones first. The fact that we have not implies that 3I Atlas is a statistical outlier or perhaps belongs to a distinct population of dense, resilient interstellar remnants. While Loeb has speculated that its density, trajectory alignment, and reported chemical anomalies, such as tentative detections of nickel without accompanying iron, could hint at non-natural origins, NASA and ESA scientists caution that the evidence remains entirely consistent with a natural cometary body. The observed outgassing, the measured composition, and the diffuse coma all point to a frozen nucleus of mixed volatiles rather than any kind of engineered object. Some researchers are exploring bold new theories to explain what interstellar comets might represent in a broader cosmic context. Among them, astrophysicist Suzanne Falsner has proposed an especially intriguing hypothesis that objects like 3I Atlas could serve as planet seeds, preformed solid cores that, when captured by a young star system, trigger the rapid formation of gas giant planets. In conventional models of planet formation, tiny dust grains within a protoplanetary disk gradually collide and stick together, forming pebbles, then boulders, and finally kilometer-scale planetesimals. However, this process is slow, and protoplanetary disks often dissipate within a few million years, possibly too quickly for giant planets like Jupiter or Saturn to have fully formed. Falsner's model suggests that if an already large interstellar body, perhaps tens of kilometers wide, were to fall into such a disk, it could act as a ready-made gravitational core, immediately attracting gas and dust and accelerating the birth of a planet. Her simulations indicate that massive stars are more likely to capture such interstellar wanderers, and indeed, observational data show that gas giants occur more frequently around larger, hotter stars. The correlation strengthens the idea that some planetary systems may have been seeded by interstellar travelers like 3I Atlas. If true, this theory redefines the role of interstellar objects from passive drifters to active participants in cosmic creation. Rather than random debris, they could be agents of planetary genesis, carrying the raw materials and structural mass needed to kickstart planet formation wherever they wander. It is even possible that early in our own solar system's history, such an object contributed to the rapid accumulation of material that formed the gas giants. Whether or not this particular comet had such a role elsewhere, its observation represents an unprecedented opportunity to study the chemistry and physics of material formed around another star. For now, scientists continue to analyze every photon captured by orbiters and rovers, working to distinguish signal from noise, motion from artifact, and natural behavior from anomaly. Despite social media speculation about alien technology, the consensus view is that 3I Atlas is an unusually massive but natural interstellar comet whose behavior is consistent with known physical principles. It is brightening gradually as it nears the Sun, showing a stable coma but no signs of fragmentation. Its orbit confirms that it came from outside the solar system and will leave it again, carrying with it chemical fingerprints of its birthplace. The ongoing collaboration between ESA and NASA exemplifies how planetary science and astrophysics can converge to study a phenomenon that connects both fields. The event has also underscored the flexibility of spacecraft originally designed for entirely different purposes, which can be repurposed to study unexpected phenomena. CASSIS, HiRISE, and even the humble NavCam on Perseverance have demonstrated how instruments meant for geology or atmospheric monitoring can contribute to interstellar science. As of October 2025, 3I Atlas is now one of the most thoroughly observed interstellar visitors ever detected, with data coming from Mars orbit, the Martian surface, Earth-based telescopes, and even space observatories. Each new observation refines our understanding of what interstellar debris looks like, how it behaves near the Sun, and what it can tell us about the diversity of material between stars. Whether as a massive comet, a planet seed, or simply a scientific curiosity, 3I Atlas stands as a reminder of how dynamic and interconnected the universe truly is. Its discovery and study highlight the growing capability of planetary missions to contribute to astrophysical research, expanding the boundaries of exploration from our own planet to Mars and beyond. For now, as it speeds toward perihelion and then out into the darkness between stars, 3I Atlas remains both a messenger and a mystery, a fragment from another world, glimpsed in unprecedented detail by the robotic explorers of two worlds, working together across the solar system.